All right. Hello and welcome to another episode of Containers from the Couch. Today is a part two of a series we've kicked off going through the all new EKS workshop. You can always find EKS workshop at, very simply, eksworkshop.com. Today, I'm joined by my guest, AWS Principal Developer Advocate, Sheetal Joshi. Sheetal, how are you doing today?
I'm good. Super excited to be back on the couch, I guess. Let's kick it off.
Awesome. Let's do it. Okay, so again, I'm your host, Cy Venom. Sheetal is actually my teammate and a subject matter expert on all things networking with Amazon EKS. With this all new workshop, which we've rewritten and revamped in 2023, we're addressing common and popular use cases that Amazon EKS customers and just Kubernetes users in general tend to run into. So challenges and requirements. Today, we're going to be focusing on some networking use cases. Sheetal's got an existing environment of the Amazon EKS workshop up and running. By the way, folks, if you want to follow along at home, you can always deploy your own version of the EKS workshop environment, going to the in your account setup steps, following the steps there. Of course, there's going to be a charge associated with running the EKS cluster and some of the necessary dependencies there. But you can follow along at home or watch this video to watch an expert, Sheetal, do it. Please, if you have any questions throughout our episode today, feel free to drop a comment. Or if you're watching this recorded after the fact, feel free to drop a question in chat and we'll get back to you. Okay, so Sheetal, now that we've gotten the kind of prerequisites out of the way, I think we want to jump right into it. I know we've got a very demo-heavy presentation today. Of course, we're going to be running through the workshop. Let's start with what the first module in the EKS workshop is going to be. And I think you've got some precursor information for us as well, right?
Yeah, thank you, Sai. Today, we'll be covering everything about EKS networking, right? And as we all know, Amazon VPC CNI is the heart of it. I thought it's better we talk about some of the Kubernetes networking primer before we kickstart the workshop and understand what CNI is and how VPC CNI behaves, right? I'm sure like most of you joining already have some kind of Kubernetes experience and know about CNI, but anyhow, we'll just go through some of the basics here. So Kubernetes networking tenets, as we all know, it mandates that all containers should be able to communicate with other containers without any super of the complex NAT being involved. And also the IP address that the container sees itself is the same IP address that others see as well, right? So how does Kubernetes solve this networking problem? Something called as container networking interface. And networking interface is a specification for Kubernetes on how pods get an IP, how pods communicate with each other, right? And CNI also assign a network namespace and a network interface to the pod at the beginning of the pod startup. And it assigns an IP address to a pod, and it also mandates that cleans up the network namespace when the pod terminates without leaving any residue behind. And how Amazon EKS solves this pod networking problem is using the Amazon VPC CNI. We architected VPC CNI in 2017, and it integrates natively with the Amazon VPC, one of the battle-tested software-defined networking on the earth, and there is no overlay networking involved, right? And it also provides sub-second latency for the pod startup as well as the pod communication.
So Sheetal, I just want to make a quick comment here. That integration between Kubernetes and the VPC capability in Amazon means when we start working with Kubernetes today and we start doing things like creating services and exposing applications, a lot of the times there's actually a step here and you say, oh, let's go to the console and see the actual changes in the VPC. And I think that's really interesting where no matter what you're working with within Kubernetes, it's tied directly to those VPC concepts. And that's something we're going to see today as we start doing things with the cluster. We will be able to see that it's actually driving behind the scenes changes in the Amazon VPC capability.
Exactly. And I think I'll just also go through some of the details and it will kind of make it clear, right? So, what exactly those calls are and how does it make an API call and how does it all work? So, just like whenever you try to schedule a pod, you use a Kubernetes API, right? And Kubernetes API hands it over to the scheduler, and scheduler actually says, okay, this node is free. Let's go ahead and deploy or run this pod on this node. It invokes a kubelet, basically. It invokes the CNI add or the delete commands for the pods. If you are basically scheduling a pod, then it's going to invoke an add command. Amazon VPC CNI, as you see here, has two components, right? A CNI binary as well as IPAM, the plugin. So what actually both of these things do? So you can provide the CNI plugin to a kubelet using the network plugin command, and you can also say this is where my configuration file lies for a CNI binary. And when a pod lands on a node, the API server, the kubelet, and the CNI plugin components work together to assign an IP address to the pod, sets up the pod network namespace and also the host namespace using the veth pair that we will just see in the next slide, then also updates the route tables on the node itself. So what does this IPAMD plugin here? As Sai just mentioned, basically it integrates natively into the VPC. That also means we are assigning an IP address from the VPC sider to a pod, and that's what IPAMD is taking care of, talking to the VPC and the EC2 control plane APIs, making sure there are enough IP address so that these VPC IPs can be assigned to a pod. Yeah,
We've actually got a question in the chat already from Tarek. I'm actually curious to know the answer myself. Does EKS use pause containers for pod networking and IP? So essentially, I'm guessing to be able to reserve the IP addresses, like a secret container to be able to reserve them.
No, that's what basically in IPAM-D, which is AWS node daemon said that if you're seeing on a node, that does the job for you, right? It's always running. It sees how many IPs are available to be assigned. If not, it makes a call to the control plane APIs to reserve those pool for you, right? So that's what it says here. Like CNI plugin attaches an ENI to the worker node. And also there are settings called as warm pool settings, which typically we call it as warm ENI target or the warm IP target or the minimum IP target that you can configure, right? So what IPAMD is doing is basically it looks up at those values and then it assigns a warm pool of secondary IP addresses or maintains the warm pool of the secondary IP addresses, right? And when a pod actually lands on a worker node, it is assigned that IP address from the pool. It's constantly running, and if it sees that pool is depleting, it makes sure it keeps an additional ENI and also the number of the IPs that can be allocated for that ENI.
Awesome.
Hope that kind of makes it clear.
Yeah, that makes sense.
Yeah, and as and when the IP addresses on ETH0 are exhausting, right? They're assigned from an ETH1 and so on. And also because what a CNI does is here, it assigns the IPs to the pods and also assigns those IPs back onto a node as a secondary IPs. And that makes it number of pods on a worker node to be limited by the number of the IP addresses and the number of the ENIs that a node can handle or an instance type can handle. So whenever you are actually selecting the instance type for your nodes, please be aware of the number of the ENIs and also the IP limits for those ENIs. So the next is prefix delegation. As we just saw, when you actually schedule a pod, a secondary IP is drawn from the pool and that IP is assigned to a pod. And this means you are limited by the number of the secondary IPs that can be assigned to an ENI. And this is where a cool feature, which is called as prefix delegation, comes into handy. And in here, what happens is instead of just having a secondary independent IP, you can assign a /28 prefix And the /28 prefix is a constant, regardless of the instance type. You can just assign /28 prefix. The first IP on an ENI is reserved for the primary IP, and all the other 15 IPs are for the pod IP assignment on that prefix. And when a pod actually lands on a worker node, it is assigned an IP address from within that prefix. So just in case, like as an example, if an instance type support 3 secondary IPs in here, you should be able to assign 3 prefixes, which tremendously increases the number of the pods that you can be running on any node.
So Sheetal, we've got a couple of questions coming in, and I want to bring those up while you have that chart up. So from Cloud Surfer 22, as a best practice, what should be the CIDR ranges for a subnet? Of course, I think we're talking about a subnet in VPC. If I understand, these subnets need to have at least 6 IP addresses that EKS will use itself. So I think the recommendation is at least 16, but there we're seeing /24 in your subnet, correct?
Yeah. So there are 6 IPs that you're required because EKS uses something called as cross-account ENIs to be able to communicate with the Kubernetes data plane, i.e. the worker nodes that are running in your account. And /16, and in the example that I am using, it's a /24. It all depends on the scale and the number of the pods that you're going to be running, right? So please make sure you kind of understand the pod density and size your subnets accordingly.
Got it.
Okay, so when similar to the secondary IPs, independent IPs here, when prefixes on ETH0 are exhausted, they are assigned from ETH1. The IPAMD that is running assigns an additional ENI to a worker node in the backend, and then make sure it also keeps in the prefixes in the pool. And that value you can control using the warm prefix target as well. So let's go ahead and jump into the workshop itself. So we have, at least I have provisioned an environment here, right? And what I'm sharing as part of that, the workshop is the workshop infrastructure already set up clusters for you. It's a single cluster, right, Sai? If I'm not wrong, we just spin up a single cluster at this point of time.
That's right. That's right. A single cluster. It's a few node groups in there, but really just one that we're going to be working with. As you can see here, the 3 node groups that are populated in the console. For folks that are watching at home and want to follow along, of course, you can follow along with us here today, or spin up your own copy of this environment. We have Terraform-based instructions that allow you to spin up this entire environment in your own account. And of course, if you're working with your favorite field seller from AWS, maybe they're running this event for you, you would get access to an environment as well. For example, if you're running a workshop at an AWS event like reInvent or a customer event, you would also get access to an environment like this.
Yeah, so I have the cluster running, the node group already provisioned. So let's go ahead and look at the VPC CNI setting here. For the purpose of the efficiency, when you spin up this workshop, the VPC CNI is already running in a prefix delegation mode. So I'm just clicking on one of the instance here, one of the worker node. As you can see, there are 2 ENIs that are configured on that node, and already 2 of the prefixes configured. So why is that so? Sai, when while I'm bringing up the console, can you talk about the sample application that workshop uses?
Yeah, definitely. So obviously, AWS, Amazon Web Services, we've got to make our own e-commerce sample application. I'll tell you folks, if you want to learn more about the sample app, even outside of the context of just EKS, we've developed this app to really be a demonstration of container capabilities. So I'll drop a link to it in the chat here, but you can deploy this as containers on App Runner, on Amazon EKS. I believe we've also added support for things like Docker Compose. And really, it's just a microservices-based application. It demonstrates a number of capabilities, including stateful, stateless applications, as well as message queue services. At the end of the day, just a simple retail e-commerce sample app made up of a number of different microservice components. And you can see those here by listing the pods. Well, in addition to all of the different services that we have running in the cluster, the pods that are making up the application itself.
Yeah, and we also have some of the bare minimal add-ons that are required, or which can, I think, help us understand the application a little bit more. So as you can see here, there are a lot of applications that are running. The pods are already running, and that's where when I went to the instances, here you can see basically the network being configured and ENIs being configured, and prefixes are already assigned. So let's go ahead and look at the internals of the VPC CNI itself. So what I'm going to do here is I'm just going to describe the AWS node. It says, yeah, the CNI is running, and 1.12.6 is the version of the CNI. And let's see the settings of the VPC CNI itself. Yeah,
so
as you can
question in chat, Sheetal. I think maybe we need to step back just a second. What is
Sure.
delegation mode? So of course you mentioned that the cluster already has prefix delegation enabled. And I just want to say, we're about to answer this question from going through the workshop itself, but maybe it's worth talking about really quickly, Sheetal, what it means to have a cluster with prefix delegation enabled. I know we did it already in this EKS cluster, but can we quickly talk about how one would enable that?
Yeah. So as we explained before, actually the pods receive an IP address from the VPC CIDR, and then those IPs are also assigned as a secondary IPs on a worker node, right? That kind of limits to ability to run more pods on a given node. And you might see your resources, especially your worker nodes, are underutilized. So VPC launched this cool feature we call it as prefix delegation, and also you will see in some of our docs prefix assignment, right? Instead of a single IP address, you can now assign a /28 prefixes to the ENIs, right? If a ENI supports 3 secondary IPs, now in case of 3 individual secondary IPs, you can assign 3 prefixes of /28 size, which means instead of one single IP, there are 16 more IPs that you can draw your IPs from. So that tremendously increases your pod density on a given worker node. If it was 19 pods on a given worker node, with the prefix delegation, that number might increase up to 110 on a smaller instances, and on some of the larger instances, now you can run pods up to 220 as well.
So basically, depending on the type of node you have, Sheetal, you're limited to the number of IP addresses that are available. That limits you for the number of pods. Now, of course, customers might want to deploy many smaller pods on a smaller instance, and to enable that increased pod density, you can enable prefix delegation to essentially give the ability for more of your pods to be assigned an IP address.
And then maximize your resource utilization on that given node, right?
And that's exactly, I think, what we're going to be seeing today with this first lab.
Exactly, yeah. And then the way that you enable prefix delegation is using this flag. As we said, we enable prefix delegation on the workshop. As you spin up the workshop, the prefix delegation is automatically turned on. It's the workshop infrastructure that is enabling the prefix delegation, but if you are actually running, like creating your own cluster, the VPC CNI still runs in a secondary IP mode, and you can follow the steps in our user guide and also the steps mentioned here on the workshop to enable the prefix delegation. So,
what we've done there is double check that the prefix delegation is enabled. Okay, and now in this step, well, I'll let you explain it.
Yeah, so this is same thing, right? I just explained it through the console. I showed the number of the prefixes, and we are just using the AWS command line here to show for each of the instances how many prefixes have been assigned.
And for our folks watching at home, essentially what this CIDR range is denoting here is that we've got the /28, so the 28, the 4 bits here will lead to 16 additional IP addresses. And you can somewhat kind of see here, for example, in that very bottom one, that's 10.42.10.64/28. So the one right below that one, right, Sheetal? So if we added 16 to that one, that actually gets us to the next one that's right below it, the 10.42.10.80. So you can see how that /28 corresponds to 16 reserved IP addresses. And those two together make 32, and the 3 for that instance will make, obviously, 48. So that's kind of the number that we have associated here.
Yeah, and you see on this instance, there are 3 IP prefixes, and maybe on the other instances, there are 2. That's just because there are more pods that are being, scheduled on this node.
Got it. So that's dynamic. As we schedule more pods, more prefixes get created?
Exactly. So let's see here. So what I'm going to do towards the same question, right? I'm just going to run one of the pods container here, right? It's just, we will spin up 150 pods and see how prefix delegation actually works in action.
Okay, so 150 pods. If we didn't have prefix delegation enabled, we would clearly run into a limit here. Well, that's
so let's see. Yeah. So maybe I'm not in the wrong, or maybe I'm not in the right.
The namespace is not. I think I know what's going on here, Sheetal. I think you just need to run the reset environment command, because the first time you access this environment, it doesn't actually deploy the sample app and the namespaces. So for folks that are watching at home, the very first time you spin up the EKS cluster environment, the first step in the introduction is actually guiding you through deploying that sample app that we just talked about. But we've made the lab modular. So if you want to just skip the intro, you're an expert, you want to jump right into the networking module, we created this handy reset environment command, which enables you to get that environment up and running, ready to go, so that you can actually jump right into the prefix delegation step. Sheetal, I'm guessing you usually work with a cluster that's already run this command before, but working with the new environment, you do have to run that.
Yeah. And each of our page actually describes that, we recommend you to run this reset environment. But if you're just going from start, beginning to end, then it's all fine. But if you're just jumping across different sections, please run reset environment. Don't make a mistake that I made. Just me.
While we wait for that to get ready, we've got another question in the chat. Is IPv6 supported? And so I want to say yes, but with some caveats, right? And Sheetal, I'll let you elaborate.
Yeah, yes, we do support IPv6 today, and IPv6 is supported in a prefix mode by default. However, we have not added IPv6 section to the workshop as of yet. It's coming soon. I think we just wanted to keep simple for the initial part of the workshop so that everybody understands different concepts of EKS networking and go in detail of the VPCCNI and the different mode that VPCCNI supports. But of course, we do support IPv6 and we do support IPv6 in prefix delegation mode.
Excellent, excellent. All right, I think the app should come up any second now. I've never had this command, take longer than a couple minutes. Oh, there we go. Now we should be able to go to that first step there.
Yeah, let me go to that section. Let me go ahead and try apply. Yeah, cool.
So what we're doing now is just deploying 150 copies of a very simple POS container, right? And Kubernetes will, anytime you spin up a pod, it's going to assign an IP address to that pod. Now, of course, these are cluster IPs, so the IPs are not accessible externally. It's just a way if you're within the Kubernetes network, to be able to, for the pods to be able to communicate with one another. So I'm guessing this should happen fairly quickly, 150 pods. But what's probably more interesting here, Sheetal, is while this is happening, can we run that command again to see the IPv4 prefixes associated with every instance ID?
Yeah, I think all of the pods are up and running too. Let's just go ahead and see if we have, yeah, they are all up. Now we should see more prefixes. Yeah, okay. As you can see here, some of those pods that we just ran landed on to the instance where it has only two prefixes before. Now you see additional 5 prefixes being assigned.
Right, and even for each node as well, because those pods are being distributed across the 3 nodes that we have.
That is correct, yeah.
Okay, excellent. So it looks like it's working as expected. We've got prefix delegation enabled, which means now we have access to many more IP addresses for pods to be assigned. If we didn't have enough, what's the error that people can expect to see, Sheetal? Do you happen to know that off the top of your head?
Yeah, I mean, pods will be waiting to create, right? Because there are no IPs available to be assigned to a pod.
Fair enough. Yeah, so we just have unschedulable pods. That makes sense.
Yeah, and also there might be another scenario where we reach the max pods limit on a worker node, and then all of the pods might not be scheduled either.
Got it. And I'm guessing with IPv6, like you mentioned, it's automatically enabled. And of course, with IPv6, you just have access to way more IPs. That pod density issue is less of a challenge, right?
That is correct. Yeah.
We've got a good question come up actually again from Cloud Surfer. So as pods terminate, are those IPs reused? Does it try to assign IPs from contiguous blocks? So we start with the first one.
Okay, so what happens? Yes, when you basically delete the pods, those IPs are given back to the pool, and depending on the warm settings that you have, those IPs might not be immediately released back to the EC2 pool, right? We try to maintain the warm settings, and if those setting limits have reached, then the IPs will be released back to the EC2 pools. And yes, that's a good question, actually. The contiguous block of the IPs, if your subnet is highly fragmented, you might see an error when CNI tries to basically draw the /28 prefixes from the subnet. Then you will see a failure and it will not work. So you will have to make sure that you have the contiguous block of the IPs available. And also we recommend that you reserve the prefixes in case if you see that these blocks are not, like IP blocks are not contiguous. Yeah.
Yep. And really, we can just see here from those prefixes that it looks like it tries its best to assign the contiguous blocks when possible.
Correct.
Yeah. Okay, so is that, I think that's all that we've got for prefix delegation, right? I mean, again, just to kind of recap, this is a capability to enable customers who are running into IP exhaustion limits, pods that are unschedulable because they don't have IPs that can be assigned. This means even with smaller nodes, which don't have as many ENIs attached, you can still deploy a larger number of pods.
Yes, yeah. Before I move on to the next setting of the VPCNI, just gonna make sure I run this while it is doing the work in the background. Let me go ahead and go talk about the custom networking.
There's a step in custom networking where we have to provision a new node group, right? So,
yeah, maybe that's a good idea. So let me go ahead and do that as well.
Yeah. I figured that might be a good thing to just get that node up and running. I think it's in the third step, the provision a new node group step.
Yeah.
So we're just doing some magic behind the scenes here. Folks, if you're running through this at home, of course, go step by step. I think one more step, Sheetal, and then you'll see it. One more. There we go. One of the steps in this module, we have to create a node group. Creating a node group takes a variable amount of time. I'd say about 5 minutes or more. So we want to just go ahead and run that in the meantime.
Yeah, and we will explain why is it really required when we get to this step of the workshop. Just wait here until this reset environment command completes. Okay, great.
So
So I'm
we've got
just,
a question while you run that, Sheetal. Oh, okay,
Mhm.
awesome. Got it creating. Does prefix mode, prefix
Mhm.
assignment mode, prefix delegation mode, whatever you want to call it, does it add more ETH, Ethernet endpoints to the instance? I
So
think the answer is no,
yes,
but I'll let you elaborate.
yeah. So if you look at in the contrary, maybe you might see a fewer ENIs than in the secondary IP mode because you are able to schedule more pods, right? And maybe just one prefix might be just enough for the instance type that you are on and the number of the pods that you are scheduling. So it's not assigning more ENIs, probably reducing the number of the ENIs on the worker node that
And
you will.
what does the ETH stands for? Like, so in the diagram you have ETH ENI, so the elastic network interfaces. What is the is that Ethernet?
Yeah, where do you see which diagram?
I think it was in one of your previous diagrams. Yeah, the ETH
This
one.
is the ETH0 and the ETH1, right? That's how you will see on the worker node. But these are the elastic network interfaces that are assigned to the node itself.
Right, that's right. All right, so we're on to custom networking now. We've got the prerequisites spinning up in the background. What do we got here?
Yeah, so we saw how VPC works and what secondary IP mode is and the prefix delegation. And with the prefix delegation, you kind of solve the pod density issues. And typically, pod networking in the VPC CNI mode, like the VPC has a primary CIDR, and also node and pod IPs are assigned from the same address space. And in most of the scenarios, what we hear from the customers, they have been using the VPCs that have been designed before the Kubernetes era, or also they did not know how VPC CNI works, or probably they might be using a different CNI and they have actually created a smaller subnets, right? And the CIDR is full. There is no more space for assigning more IPs from that CIDR. And that's where custom networking comes in. Custom network, again, VPC CNI, the main tenet, provide all of or integrate with all of the cool features that Amazon VPC supports, right? And one of that is also able to assign the secondary CIDR, and that way you can extend your IP availability to the cluster. So what happens is you can go ahead and attach a secondary CIDR to your VPC, and this secondary CIDR is typically from the CGNAT space, like 164 space. And when you assign the secondary CIDR, you will follow all of the best practices that are laid out by the Amazon VPC itself. And EKS kind of just follows or piggybacks on the Amazon VPC best practices for assigning the secondary CIDRs. You will set up the subnets with the secondary CIDRs. As you can see here, I have created two private subnets. I think part of this exercise we are using 4 subnets, but we will see when we get there. And here the worker nodes receive an IP. The primary IP of the worker node itself is from the primary CIDR, and the pods actually receive an IP from the secondary CIDR. And the way that it works is just like other configuration or the parameters that VPC supports, you can actually enable the custom networking using the custom network flag. And VPC CNI supports a custom resource definition called as ENI config. And this is where you will say, this is the subnet that I'm going to be using for a particular availability zone. And when you specify that, and when you try to schedule a pod, the config that is applied to that zone and on that node will be used, and your pods will be scheduled on the secondary CIDR subnet. So let's go ahead and see it in action. So this is one of the sample ENI config. So by default, if you are not using your custom label, the zone is used. Like what you can see here is this ENI config is named as US West 2A. And also the security group that you want to be assigning to that ENI and the subnet that this particular ENI config is going to be using to assign an IP to the pods.
So I have a question here, Sheetal. We talked about prefix delegation. Now we're talking about custom networking. Can you talk about the use cases where one might want to use prefix delegation versus custom networking for the IP addresses issues?
Yeah. So custom networking is typically when you're seeing an IP exhaustion, right? Like your CIDR, like you have used up all of the addresses, available addresses in your primary CIDR, and you want to basically assign a secondary CIDR so that you can schedule more pods. Prefix delegation is you still have IPs available in the primary CIDR, right? And you want to increase the density of the pods. That means you want to run more pods on a given instance. That's when you will use a prefix delegation. However, you can use prefix delegation along with the custom networking. So what does that mean is whenever you have enabled prefix delegation along with the custom networking, basically you are applying the prefix delegation on the secondary CIDR, right? As the pods receive an IP from the secondary CIDR, you can also actually apply the prefix delegation. Instead of the secondary IP, you are basically assigning a prefix from the secondary CIDR, thus giving you best of both the worlds. You are also increasing the pod density on a given instance or a worker node. Along with that, you're able to scale beyond your IP limitations.
Gotcha. And so combined, that's something that is very much possible to further increase the number of IP addresses.
Exactly. Yeah.
Awesome.
So what I'm trying to do here is just trying to see what are the CIDRs that are actually applied to a VPC, right? So as part of the workshop infrastructure creation, we have already created a secondary CIDR. Here, as you can see, 164.16 has already been assigned to this VPC. And even when you are running this workshop on your own, when you spin up a workshop, you will see both the CIDRs have been configured. We are not using the secondary CIDR yet. We will see how we can apply that or how we can leverage the secondary CIDR in a bit. So let's go ahead and describe the subnets and this. Yeah, you will see we have created subnets both in the primary CIDR as well as the secondary CIDR in each of the availability zones that are available for the cluster. So this is how it's going to look like. As you can see, there are 3 private subnets in the primary CIDR and also 3 secondary subnets that have been created across 3 availability zones. So let's see what are those subnet. Yeah, these are the subnet IDs. And let's go ahead and set the custom networking config flag to true. And this ENI config YAML is just describing, the subnets that we just assigned. And these AZs are mapped to the availability zone that we just shared in the previous image. So let's go ahead and apply these ENI configs to the cluster. Yeah, so the ENI configs are available. And let's examine when we actually have applied the configuration. It also requires that we have to enable the label. By default, it is mapped to the zone. And also in this example, we are just using the zone availability zone labels. If you have a different requirement and if you want to use if you have multiple subnets in the availability zone, just using the availability zone level is not going to be sufficient. So you might want to create a unique label to be used so that pods are scheduled on the different secondary subnets that are available within that zone. And here we already performed this step, like actually creating a node group. And why is this important? Custom networking is not going to be enabled by default on the existing nodes. The pods that are running on an existing nodes will continue to be running with the IPs from the primary CIDR, right? And whenever you are seeing an IP exhaustion issues, or whenever you want to basically deploy these pods onto the secondary CIDR, we recommend you recycle the existing nodes. If you think that you're fine with the existing applications running in the primary CIDR, you can leave that node group and the pods running on that node group, and then create the new node group for the new applications that you want to deploy in the secondary CIDR. But we recommend that you recycle the nodes for the pods to be getting an IP from the secondary CIDR. So let's go ahead and see that if that node group was created, fine.
Okay.
Yeah, so it is.
It got created.
It got created.
So I had a quick question. So you set the daemon set on AWS node, telling it to enable the custom networking capability. Now, any pods that we've already deployed are not deployed on this new node yet. So they're going to be the 10 dot instead of the 100 dot IP address ranges. Now, I guess my question is, do you need to explicitly define whether the pods are deployed on one or another, or can you just let Kubernetes handle it, and it'll automatically, spread the load of the pods across, custom networking enabled and non-enabled nodes?
That is completely fine if you think you have IPs available in the primary CIDR, then you can do that, right? And, actually, Kubernetes, to do the magic for you. But if you think you're already running into an IP exhaustion issues in the existing CIDR, then just doing that is not going to help you.
I see. And I think another way to phrase this is a question that just came in chat. So with custom networking enabled, which CIDR takes precedence for new pods and deployments? And then for the existing pods and deployments, as we just discussed, they won't be rescheduled until at least you restart them, or you tell them, with the node selector, like we're about to do, to be rescheduled onto the new one.
So at least in this example, what we have done is we have actually labeled the node as custom networking, right? I am declaratively telling, okay, I want this checkout applications to be deployed on a new node with a custom networking tag so that it receives an IP from the secondary CIDR.
Right. Otherwise, it's, luck of the draw. It could go on the first one, on the first 3 nodes, or the new one that we deployed. Depending on which one it gets deployed, we would get either one of those 10 dot IP addresses or the 100 dot in the secondary IP ranges.
Correct, yeah. Okay, let's go ahead and run this sample app.
So what we're doing here is we're customizing the checkout app. So the deployment's already there, but now we're saying let's update that deployment and add this node selector to do to tell it to deploy the checkout deployment pod on the custom networking node. So it's just looking for any node with that label enabled on it.
Yeah, and another thing that to note here, right? So everything is VPC Fabric. When you create a new CIDR, no additional changes are required at a networking level, right? The VPC Fabric is going to be taking care of basically the networking across or the communication across these different pods.
That's right.
Yeah. So the sample application, the checkout is now running. As you can see, only checkout app has, or a checkout pod has an IP from the secondary CIDR versus all the backend pods that this checkout depends on still runs on a primary CIDR on an old node.
That's right. So when we created that deployment, Kubernetes realized, hey, the config changed. We need to restart this pod. And then that's what enabled it to work. Got it.
Yeah. Mm-hmm. So how do we clean up? I think that's a critical thing too. And just go ahead and reverse all of the setup. I'm just telling disable the custom networking by just setting it up to false. And I'm just going to go ahead and delete the node group, additional node group that I have created. And I'm going to also revert back my checkout app to be running on a primary cider. Yeah, just applying that customized.
It's definitely valuable to see how this works, to see the cleanup. But folks that are following along at home, I think one of the things we've done, Sheetal, is also program this into the reset environment command, right? So anytime the user runs reset environment, say you got halfway through the lab and then you've decided, hey, I want to go to the next lab, just run reset environment and we'll get the environment back to a regular state so you can be kind of sure that further modules will continue to work as expected as well.
Any questions on the custom networking that you're seeing, Sai?
Well, I think we've addressed most of the questions on custom networking here so far. I think, let's see, for folks that are watching, reading along, if you have any other questions for how some of these things are working, please drop us a question here. We're resetting the environment before we move on to the final module in the networking piece, which is going to be security groups for pods.
Yeah, and another thing to actually note here, right, when you are basically using the custom networking, the primary ENI, E0, is going to be getting an IP from the primary cider. So technically, one of the ENI is kind of not used with the secondary cider here. So your pod density is going to be affected slightly, yeah, when using the custom networking. There is one less ENI available for the pod IP allocation. So pod density, when compared to the regular pod networking, is less when using custom networking.
Right. We do have a question coming in here, Sheetal. So from Tarek, how does CNI play into EKS Fargate clusters? We don't have to assign prefix delegation or custom networking in Fargate, right?
No. However, basically, the next option that we are going to be showcasing, you will see how that is extensible to Fargate as well.
Yeah, and Tarek, I know you had an earlier question as well about third-party CNI plugins that are also available. So one thing I just want to clarify here is that the VPC CNI plugin is the only one that's officially supported by Amazon EKS, but you can work with other compatible CNI plugins, Isovalence, Cilium, or Calico, and a number of others. I think our recommendation is that you should get support from them if you want to use those CNIs. And of course, here being upstream conformant version of Kubernetes in Amazon EKS, you can use any CNI of your choice. But we do recommend and support Amazon VPC CNI plugin.
Yeah, so Fargate is just like its own independent task or a unit, right? So
yeah, right. I guess Fargate only supports VPC CNI if you're running in Fargate.
Okay, so let me see if yeah. So what's happening here? The node group is deleted. I'm just going to go ahead and apply the checkout patch. Yeah, and then also run the reset environment while we go through some of the basics of the security groups. Sure. So security groups, right? Each worker node has a primary ENI and one or more secondary ENIs that we just saw. Pods are assigned an IP from the secondary IP addresses. And in this setup, worker node and all of its pods basically share the same security group that is attached to the primary ENI of the node. There are many cases wherein you want to use the security groups for a pod separately and not want to use the security group that is assigned to the worker nodes, right? I think one of such scenario you can think of is like you you are running basically a backend pod that requires an access to an RDS database. And most of the organizations have already built some of the compliance programs around the security groups, and they like the AWS security features that security groups provides them, and wanted to extend those similar features to the pods running on Kubernetes, right? And they wanted to reuse all of the operational knowledge, tooling, and experience around the security group policies rather than implementing the Kubernetes network policies. That is one way to think about. And this is what exactly security groups for pods is offering you, right? With the security groups for pods, what you can actually do is assign a separate security group for a pod. And how does VPC makes it happen? You can, of course, enable it using a different setting called as enable pod ENI. So what happens when we do that? There is a resource controller that is running, VPC resource controller that is running on a control plane. And it creates a trunk ENI, and it attaches that trunk ENI to the node. And you can define a pod security group policy, which is again a custom resource. And when you actually apply the security group policies to a pod, the VPC resource controller that is running on a control plane creates a branch ENI. And actually, whatever security group that you have defined under the security group policies is assigned to the branch ENI. How this is a sample of the security group policy. So what we are doing here is it's like a sample Python application. And when you, for the given selectors, what I'm saying here is, okay, go ahead and apply this specific security group. If you are deploying a Python app, you would want to run it against the branch ENI and then apply this specific security group. As you will see here, all of these trunk ENIs and the number of the branch ENIs for a given trunk ENI interface is additive to the number of the pods, like the max pods that you can run on an EC2 instance. Maybe there is a link that I can share in some time where it shows the number of trunk ENIs and the number of the branch ENIs that you can be creating per EC2 instance type. Yeah, and worker node gets a label which says, okay, has trunk attached. And only when that label is available, the resource controller knows about it, and the trunk is created, the pods are basically scheduled on that node, and the branch ENI is created, and the security groups are attached to that.
Got it. And when you enable this mode, Sheetal, to use the security groups per pod, do all the pods that don't specify a particular security group policy, do they just default to the standard?
Yeah, they just default to basically the standard security group, which is assigned to the primary ENI of the node.
Got it. And then for any pod that actually has that additional security group policy, a trunk ENI gets created. Again, this comes back to our use case of, what if we have a specific pod that we want to have a different egress policy attached than another pod, right? So one pod you want to restrict to internal access, and another pod to allow external. One approach we might say just put them on different nodes. But of course, there's always going to be a use case where we want to have pods to have fine-grained access controls, even when running in the same node. That's really where this feature comes into play, right?
Exactly, yeah. And like you have front end, we have back end, and your API pods which are running on the same node, and you want to maximize the resource utilization of a particular node, then this is a great feature to use.
Excellent.
Yeah. So let's go ahead and so we are going to use the same catalog application here. And the catalog, we have the MySQL also running within the cluster. And what we are going to do as part of this exercise is going to be creating an external Amazon RDS service and allow only catalog application to be talking to the RDS service, right? So let's go ahead and see if the catalog pods are ready and running. Yes, they are. And let's look at what is the database endpoint that it is pointing to right now. So it's just pointing to the in-cluster MySQL that is running. We are going to change this catalog application to connect to the Amazon RDS instance.
Now, I like that with this module, we're killing two birds with one stone. We're showing how folks can integrate and migrate a built-in database to a managed service while showing the best practice of the networking considerations using security groups for pods. That's really interesting. Yeah.
So as you can see, just the DB endpoints are again, this is a config map basically, right? Where we are storing in all the secrets and also the DB endpoints. And here it's still pointing to the catalog MySQL. And we will just go ahead. We have created already RDS database here. So let's see if that RDS database is available in this environment. Yeah, so it's basically EKS workshop catalog endpoint. And I'm just going to go ahead and apply the change here. So it's just again a customize that we are going to be applying and changing the endpoints to use the catalog RDS, right? So all that is done, applied the change. It seems good. Let's go ahead and see. Okay, yeah.
And for folks watching at home, what we're applying here are YAML changes using Customize. Customize is native Kubernetes configuration management. It's actually integrated directly into kubectl, and you can apply it using -K. The reason we use Customize in the workshop is to make it really straightforward to see exactly what is changing. Sheetla, if you don't mind scrolling back up to that Customize and going to the diff tab in the actual instructions.
Okay.
If you go to the diff tab, it'll actually, I guess we didn't use that here. But regardless, point being, you'll notice there's a couple of other here. There you go. There it is. If you hit diff over there, you can see exactly what we've changed. So the patch itself could be kind of long and complex. This clearly shows you all we're really doing there with this particular one is changing which endpoint the catalog application is using. Not the built-in MySQL, but the RDS that we've already deployed as part of this environment.
Yeah, so I went ahead and applied the patch, and what we can see here is, yes, the database endpoint is now changed to the RDS. So let's, okay, so what we want to do next is, okay, is it applied properly? Okay, yeah, that's good. We would want to recycle this pod, right? Because to be able to connect to the RDS, let's go ahead and recycle it so that the new config map changes are pulled in. Let's wait for a few seconds for the changes to be applied. So the security group, basically that's going to be used by default is going to be the one that is assigned to the primary NI, and that doesn't have actually any access enabled to the RDS endpoint. And we can confirm that here using, okay, when I...
In fact, we expected that timeout to happen here, right? Because using a default security group. In fact, if we went into the Amazon console and the VPC and we went down to the security group for this particular subnet, then what we would see is that there's no outbound rules set. That basically means there's no way for any pods within this security group on this node to even access a service outside of the cluster. And so obviously it's going to fail accessing RDS.
Yeah. So that's what is unable to connect because the EC2 security group that's been applied to the RDS database doesn't allow you to connect. So what we are going to now do is go ahead and apply a security group and the rule to enable access to the RDS database. So let's see what are the different security groups that are applied. Yeah, okay. So we have already created the catalog security group ID, and then it just allows access to the RDS database as well. So yeah, so that this is a security group policy that we were talking about earlier. Here, what we are saying is just if the pod has a component service, just enable the security group for that catalog pod. So let's go ahead and change that.
Okay, so what we've done there is essentially we need to delete the pod, right, so that it can pick up that new security group, because this was not actually a change to any config of the pod itself, but the node, the security group policy that's aligned to the node. It's so for it to pick up that change, we're manually deleting that pod to pick up the new security group policy.
So let's see if it is able to connect to the, yeah, now we see that we are able to successfully connect to the Amazon RDS database after applying the right security groups to the pod. I think, yeah, we do also have, yeah, and another way that you can actually confirm that it is using the branch ENI and the security groups that is assigned to the branch ENI is via the annotation. When a pod is created, we also add an annotation called as a pod ENI, and this is a specific ENI that has been, assigned to the pod. And I think I'm not sure if the events are still there and not rolled over. You can confirm that using the kubectl events. Let me see if I can go to the console and if you can see there is a branch ENI that is created. Yeah, so if this network interface, when I click, it says the description as a branch ENI, basically. And please remember, like if you go to the network interface, there is nothing like a trunk ENI that you can create on your own. These features are only available for AWS services such as ECS and EKS. Yeah. I don't think you can create a ENI as a type trunk today. I don't think that's made available yet.
We've got a question in chat, and I'm curious of this myself. So fairly specific here. Do the VPC flow logs actually display the accept reject logs for where these ANIs are set?
I think so. Yeah. I don't know whether did we enable the flow logs for this workshop. We should have probably gone and confirmed that.
I'm fairly certain we don't, but that's interesting, and that's
Should
something that
be
we
available.
should enable here.
Yeah.
But if they were enabled, users would be able to see the packets, whether they're accepted or not, coming from EKS pods and IPs.
Right? Exactly. At the end of the day, it's all VPC network. Yes.
Right. Good question. And that raises a good question. We should probably make sure we have a dedicated module talking about VPC flow logs, because super valuable for keeping and auditing the traffic coming in and out of your VPC, which is underpinning all your pods and applications in EKS.
Yeah, and also I think did you share the EKS best practices on the?
Yeah, you know what? I'll share it one more time, because I think it's honestly such a great resource, and we have a dedicated networking module in the EKS best practices guide, which talks about everything we've talked about today and more in depth. So I'll drop a link in chat here.
Yeah, and I think somebody kind of requested that we can add all the observability practices to the networking best practices section. Yeah, please stay tuned for updates such as VPC, flow logs, and metrics, server details getting added to the networking section.
Yep. And we got confirmation from someone else in chat that the VPC flow log does show it. So yes. Thank you, Pawan. And folks that are watching at home, I know that sometimes even partners and folks with other external open source community projects that are watching are curious how they can get pieces contributed to the EKS workshop. So folks, if you are interested in learning more about the EKS workshop, It's a completely public project. We want to govern this in the community. I'll drop a link to the GitHub in chat here. In fact, we have our first EKS workshop community call this Thursday. If you're interested in suggesting enhancements, getting involved with the workshop, contributing yourself, please go to that Google Doc that we have there. Please feel free to add that to your calendar. If you just want to leave us some feedback, that's also fine as well. We welcome, honestly, any feedback, and we ask that you, work with us through PRs or issues or whatever it might be. As an example, we have some pretty exciting stuff that we're working on in the networking module coming up here, specifically VPC Lattice, which was announced very recently. We have a module in the works. In fact, there's a PR open right now, and if you're really curious, you can actually go look through the PR and see it in its early stages as well. But it's a great way to get involved with the project.
Yeah. I just wanted to show the trunk ENI being created at an instance level, right? If you log into the console, you should be able to see it.
Oh, there you go then.
Yeah.
All right, Sheetal, I think we've got pretty good coverage here. I think we did all 3 of the modules that we have as part of the networking, and we did it pretty quickly. And, I think we had an extra 20 minutes that we thought we might need here, but, we're done a bit early. Is there anything that you wanted to share with folks here?
I think this was a great session. I would just ask people who are attending to leave us the feedback, and also if they want to see more sections added to the workshop.
Yeah, definitely. Folks, I want to thank you for tuning in. I know we couldn't get through all of the questions here. I wanted to make sure that we stayed on track. We are going to continue to do these workshop feature episodes. In fact, if you forgot, if you missed the first time we did this, going through the basics of EKS workshop, be sure to check out the link that I dropped in chat. That was an episode that I did with Justin Garrison, also from AWS, going through the fundamentals of the workshop, which is a different section. Today, we covered networking, which is a slightly more advanced topic. Upcoming, we're going to have dedicated videos where we invite the SMEs for automation, observability, security, and more. So be sure to stay tuned for that. Subscribe to Containers from the Couch on YouTube, and you won't miss any updates that we make there. Sheetal, I want to thank you so much for joining me today for this excellent session and going in so depth for the actual, for the networking piece. We had a question in chat actually asking, is it possible to get access to your slides? I don't know if you have them published, but if you want to drop a link to me, I can go ahead and add a link to the slides in the description of the YouTube. I'll probably get that in later today. And with that, Sheetal, I want to say one last time, is there anything else you want to leave with folks today?
Yeah, I just wanted to highlight the sample application. We have done a lot of work, and Sai and few of the other team members have spent a lot of time. I think it kind of helps us to understand all of the aspects of the Kubernetes. So kudos to the entire EKS workshop team.
Absolutely. It definitely takes a village here. Now that we're completely open source, we'd love to get more engagement from the community. Sheetal, again, thank you so much for joining us. All of the viewers at home, thanks for the excellent questions. We're probably going to take this video and add it directly to the EKS workshop. So for folks that want to follow along and not just read through the instructions, they can do that as well. All right, then. With that, I'll say adieu to all of you. Thanks again for tuning in, and we'll see you all next time. Let's find the music. Where's the music? Here we go.